This week we're going to carry on with the development of our Raspberry Pi device, connecting it to IoT Core and using MQTT messages to turn on and off the LED and receive the button press to action that somewhere else. One thing that I am going to do is, instead of developing on the Raspberry Pi this week, I'm going to use Visual Studio Code to connect to the Raspberry Pi and then develop remotely using Visual Studio Code and the remote development kit that comes with it, which is really cool and easy to use. I'll show you how to set that up quickly. So the only thing that we need to make sure of on the Raspberry Pi is that within the settings and the configuration that we have SSH enabled. So we can just go in and look at the interfaces there. I've got that enabled. We've already connected using VNC. You can download Visual Studio Code for free. So here's a link that I'll also put into the comment section or the info section. And you can also read about the remote development, and that'll tell you what's needed to get started. It's fairly straightforward. I'll run through it now. The first part is to install the Visual Studio Code remote extension. So if we click on this extensions button and type remote, we can see this remote SSH, and we'll install that. Okay, that's great, that's installed. So we now need to connect to the device using the normal SSH login that we would have used when we provisioned the device in the first place. So if we click on the left where we have this Remote Explorer tab, we can see that here's a list of other devices that I've previously connected to. And down at the bottom, you should see these green arrows, and you can click on those to say open or connect to a host with remote SSH. So here I can put in like pi at 192.1.40, and that should pop open in a new window, and it should prompt me to enter my login once it's finished setting that up. We can monitor the progress down in the bottom left. You can see, okay, that's good. So now we are connected, we're editing. So now we can go up to the normal File Explorer and then open a folder on the remote device. So here it's come up with this prompt to say home/pi. I can open that one. And it's asking me again for the password. It's fine. Okay, yes, I trust the authors. It's my device. So now we can see we've got the folder view of the actual device, and we can see in the components and the artifacts. So let's open one of the ones that we were working on before. So like Blinky. And in general, Visual Studio Code is a lot nicer visually to look at. Python is asking for the Python extension, so I just say yes, let that install that. I want to install it on the actual device as well. One of the other great features of this is we can do port forwarding. So if you remember in the last video, we used the debug console to see which components were running, which had stopped, and their current state. So using Visual Studio Code, we can actually connect to the device and see the remote debug console. So if I go back into this Explorer, this is going to be easier. And here, if I just open the integrated terminal, so you'll see this tab here for ports. Just get rid of that. So under the ports, I can forward a port. So the debug console used 1441 as standard and 1442. And just check that these ones are using HTTPS. So right click on the port, check that they're down as HTTPS. So now if I click on the little www or globe open in the browser there, that will pop open in the browser. So it's just popped open in the browser. I'll drag that back in. So you can see I'm getting this warning that the connection is not private, but that's fine. We can just go proceed. And then we need the login, so it's debug. We also need the password. So the way we can generate the password remotely using Visual Studio Code is we can, with this terminal, we are now running these commands on the actual device. So in my history, I've got the command for getting the debug password, so just run that command. And there we go. So then I'll copy and paste. Copy that password, paste that into this window. Sometimes it doesn't load. If it doesn't load, you might just need to browse to the port 1442 and then back again to 1441. That's sometimes a feature of the browser that stops you from doing that. But once you're logged in, that should be fine. So here we can see the local debug console, which is now on my machine, which is a lot nicer for development than using the Raspberry Pi. And I can see what's going on. I can start and stop the services. And this is what we'll use in the next example for developing the MQTT component, which you can see I've already deployed on this one and it's running, and I'll just remove that and run you through the steps to recreate that component. Let's start by creating the component on the device. So if I switch back to Visual Studio, so within our components folder we have the artifacts. So I'm going to create a new folder, and that artifact is going to be com.example.mqtt, and then following the structure that we had before, we make a new folder within that called 1.0.0 with the version, and we need a new recipe file as well to go with this artifact. Okay, so just to show that what we're working on here is a reflection of what's on the device, I can switch back to the VNC and log on to the device, and we should see that those folders, that folder structure has been created. Where are we? Components there. There you go. So you can see we've created that folder, and within that folder is empty at the moment. So let's switch back and create that file that we need within here. So a new file, we'll call that hi. So we're breaking from our convention. So now I'm going to copy the code in there, and I'll quickly go through that code as well. So this is the code that we have. Basically, this is just a copy and paste from the code that's available on the samples on the AWS website. So we can see here that we set up the button and the LED. So what this code's going to do is when we push the button on our breadboard, we're going to send a message to IoT Core up in the cloud. And also we're going to listen or subscribe to messages from IoT Core and then react to them and turn the red LED on and off remotely. So here we have the button callback, so when the button is pressed we'll just add a timestamp to a message and then publish that to IoT Core. And the second part is the subscriber to subscribe to the messages coming in. There are some inadequacies in this code, but for the purpose of demonstrating how it works, this will be good enough. So within this callback for the subscribe handler, we just look at the message and decide if it's true or false and then turn the LED on and off, and we'll be able to see that in the logs. And within the MQTT recipe, I'll pop that in now, just copy that across. That's copied across, and within there you can see that we've got this component which is our com.example.mqtt, and here within the access control there's a slight change that we have where we are subscribing or allowing these policies of publish to IoT Core and subscribe to IoT Core, which was different from, say, Lighty that we had, where we are talking to the IPC. Now we're actually talking to the IoT Core directly through Greengrass. So we've explicitly added these two topics. So one is to send, one is to publish, one is to subscribe. So essentially we can publish and subscribe on both of these, but that's not a problem for now. And within the bottom part, we can just see that it's running the MQTT Python script that's in there. So the next step is just to deploy that to the device. So make sure I save both those files in there. Then we need to deploy to the device. So I've already got the deploy command set up. So as we've done before, we do the deploy command with create, with the recipe directory and the artifact directory and the version that we wish to publish. And what we can do now, because we're doing the port forwarding using Visual Studio Code, we can actually watch the deployment happen in the local debug console. So we should see that this stops and then restarts and installs the MQTT. Yep, and now that's running. That's great. So we can see that's running. That's really good. We don't have any problems there. Let's go back to that page. So now we can test that. The best way to test it, or the quickest way to test it, is we can go into log on to AWS IoT Core, where we set up, and we can go down here to the test MQTT client. And I've got no subscriptions in there, so let's just subscribe to everything for now. And what we should be able to see is if I let me just switch the camera on so you can see that as well. So if I push this button, you can see that the message is coming in from the device all the way to IoT Core. So essentially we can use that message and forward that to any other AWS service now, or communicate worldwide with this device. So the other part that I wrote into the Python script is the ability to control it back the other way. So here we publish to a topic, and we have to follow the format that I have put in there. So if we switch back to Visual Studio Code, we can see that it's looking for this LED value, LED on, and checking if that's true or false. So basically, as long as the message contains, the JSON payload contains that LED on with a true or false, we should be able to control that. And the topic that we subscribed to was defined up here. So this subscribe topic. So I can just copy that, my pipe. And if we publish to a topic, and we need to have this as, I can't remember what it was, let me just double check. LED on, okay. So then if I paste in here true and publish that, you can see the red LED has come on. If I publish false, red LED is going off. What you'll also see is, because we have the other IPC components running, when I push this button, the LED still comes on and off, and that's because what we had with the Blinky and Lighty. So what we can do is I could just go into these and stop those for now. And if I push this button now, it won't actually do anything. So the debug console is really good in that it gives you the ability to stop and start the components and see how they're running and see what versions that you've got running on that device. Hopefully that was useful and you've got it up and running. Next time we'll look at how to deal with devices that are intermittently connected. So a device that would be offline then connects back online and synchronizes its shadow. So that would be a better way of controlling the LED, for example, so that if there is an intermittent connection and it drops, when it comes back online, it will know its state. There's two ways of doing that. One is to use the shadow service, the other is to use retained messages. And we can also look into how to get these components onto your online repository so that you can build these components locally and then push them out to multiple devices, and how you update the versions of these components on the device.